All right, so at the end of part two, we had found, at the end of part one, we had found a 0 at -2. So x minus -2 is a factor. And then my depressed polynomial was 6x squared minus x minus 1. So the next thing we want to do is go ahead and factor this. So I'm going to ignore that x plus 2 for a moment and just focus on that parent graph right here. So again, we have to do that hop, skip, and a jump to get that top value. So we're going to say what multiplies to give me 6 times -1, which is -6, and adds to give me -1. So you always want to be careful with the 6's because they can look a lot alike. So I need their product to be negative, so one of them has to be negative, and then their sum has to give me -1. So if you notice, if I do -3 and +2, their product is negative and their sum is also negative. So taking this x value, we're going to split that into these two numbers. So we're going to have 6x squared minus 3x plus 2x minus 1. Okay, so again, notice -3x plus 2x gives me back this -x right here. So we're going to group these. And so out of the first one, I have a common factor of 3 and I have a common factor of 6. So we would say 3x times what gives me 2x squared, and that would be times 2x. And then we get 3x times what gives me -3x, and that would be -1. Over here, I don't have any common factors, so my greatest common factor is just 1. And then the question is, did we do it right? And we did because we got our parentheses to be the same. So what we're going to do is, since we have that same common factor, we're going to factor out the 2x minus 1. So when that comes out, we're left with 3x plus 1. Okay. If you wanted to use the shortcut, it's a little bit more difficult than the last time because 6 is not prime. So there's two ways to multiply to get 6. It could be 6 times 1, or it could be 3 times 2. Okay, so then looking over here, do I have any numbers that I just circled that are divisible by 6? And since the answer is no, we can't use that one. But I do have one that's divisible by 3. So we would say 3 times what gives me -3, and that would be -1. And then we would say for the other number, 2 times what gives me +2, and so that would be +1. And notice we get the same answer with the shortcut as we do with the long way, and it doesn't matter to me which one you use. Okay, so I'm going to copy what I factored. So I have the x plus 2, and then we just factored that to be 2x minus 1 times 3x plus 1. Okay, so then that means that the x plus 2 can be equal to 0, making x equal to -2, which makes sense because that's what we said right here. Then we could say that 2x minus 1 is equal to 0, so that makes 2x equal to 1, and that makes x equal to 1/2. Then over here, we could say that 3x plus 1 is equal to 0, making 3x equal to -1, and x equal to -1/3. So that means that my exponent was 3. So remember, we predicted we'd have 3 complex roots, and they all happen to be real and rational. So we have found all 3 possible rational roots. Okay. So let's try this one. Okay, so we're going to list all possible roots and then we're going to find all complex roots. So hopefully that you see this word is different than rational roots, and you'll see why in just a moment. All right, and so looking at this one, I noticed that I have 3 complex roots that I'm going to need to find. And then my Q value is 1, so my Q's are going to be plus or minus 1, and that's it. And then my P values, I've got 5. 5 is prime, so I just have plus or minus 1 and plus or minus 5. Okay, so if I try, by the way, if I tried -1 or if I tried +1, they're going to give me a remainder that's not 0. So I'm going to try -5. I don't know why. So then I'm double checking. I've got a power of 3, a power of 2, a power of 1, and nothing. So I'm good. So I have coefficients of 1, 8, 16, and 5. So if I drop this, I get -5 times 1 is -5. Their sum is 3 times negative 5 is negative 15, and their sum is 1, times negative 5 is negative 5, and their sum is 1. And oh my gosh, I'm so surprised I got a remainder of 0. So we would say that this is x minus negative 5 times this depressed polynomial. So this is x to the 0, x to the 1, and x to the 2. So I have times x squared plus 3x plus 1, because x to the 0 is just 1, is equal to 0. So if I tried to factor this, do you see that I'm asking what multiplies to give me 1 that adds to give me 3? And there's nothing. So had the question said rational roots, we would be done saying the only rational root is negative 5. Okay? But I do have 2 more roots. They just happen to probably be imaginary. So let's see what happens. So I'm going to let a equal 1, b equal 3, and c equal 1, and I'm going to use the quadratic formula. So we've got x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. All right, so when I work this out, I get negative 3 plus or minus the square root of, and then we get 9 minus 4 gives me 5 all over 2. So actually I lied. We didn't get 2 imaginary solutions, but we didn't get 2 rational solutions. So we've got the solution where x plus 5 is equal to 0, which gives me x is equal to negative 5. And then we have the 2 solutions that are irrational. And so if we take a look at Desmos, let's see what that looks like. All right, so if I check this point right here where it hits the x-axis, I get my negative 5, 0. So that was my 0 of x is equal to negative 5. But if you notice over here, I get something that's not rational. I get something that's approximated. And the same thing over here. So these 2 values are real. I just don't know them as a rational solution. And so that's where those 2 irrational solutions are coming from. So coming back to our page again, we predicted 3 solutions and we got 1, 2, 3 solutions with the plus or minus. So I want you to take a moment to pause the video and see if you can answer this one on your own. All right, so hopefully you can see there's an invisible 1 here. So this is representing my Q values. So all the factors of 1 is just 1. And then for 6, we're going to get our P values. So that's going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So that's the list of all the factors of 6. Okay. So then my P over Q values are going to be all the different ways that we can do these combinations. So I've got the p-value of 1 over 1. I've got 2 over 1. I've got 3 over 1, and I have 6 over 1. So we absolutely love it when Q is 1 because P just represents all the factors, okay? So I have narrowed it down from infinity to 8 solutions. So that may not seem like much when you have to start like just guessing and checking. So I don't know why. I'm going to pick 2. And then 3, 2, 1, 0, they're in perfect descending order. So I can put these numbers in here. So we've got drop the 1. 2 times 1 is 2. Their sum is 8. Times 2 is 16. Their sum is 3. Times 2 is 6. And oh my goodness, I found another perfect remainder of 0, meaning that x minus 2 is a factor of the function. And then my depressed polynomial is going to be x squared plus 8x plus 3 equal to 0. So if you're wondering how I'm doing that magically, I made a little cheat sheet for myself up here, okay? So your homework is going to take a little bit longer, and that's why you don't have very many problems on this assignment, okay? So then if I tried to do my big X, what multiplies to give me 3 that adds to give me 8? We don't have anything, right? So I've got my one solution at X is equal to 2. And then I can say A is equal to 1, B is equal to 8, and C is equal to 3. And we can say X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. okay? So that means that we have x is equal to -8 plus or minus, and then we get 64 minus 12 gives me 52 over 2. Now, I would love to be able to cancel this -8 with the 2, but I can't because I have addition or subtraction in the middle. But looking at 52, if you understand a deck of cards, there are 4 suits with 13 cards in each suit. Or you could just divide by 4 and see what happens. So that means the square root of 52 is the same as the square root of 4 times the square root of 13, which gives me 2 root 13. So that means x is equal to -8 plus or minus 2 root 13 all over 2. So now, even though it's messy, I can factor a 2 out of my numerator. So that's going to leave me with x is equal to 2 times -4 plus or minus, and 2 times root 13 gives me 2 root 13 all over 2. So now that there's multiplication in the middle, the 2's can cancel, and I can say that my other 2 solutions are going to be -4 plus or minus the square root of 13. So I have now found all 3 complex roots, and they all happen to be real. I didn't get anything imaginary. So there's one more concept that I want to cover before we end this lesson, and I don't want to try to cut it to like 4.5 minutes, so I'm going to go ahead and do this in a part 3.